So in this video, I'll be showing you this topic, logarithms, with some examples. This topic is basically for SS1 students. So calculation using logarithms, that's the subtopic we'll be looking at in this topic, such as the multiplication and division of logarithms and what solving powers and roots in logarithms. Now let's start with the first one, which is calculation, which is multiplication and division using logarithms. Now the examples we are going to be looking at are use tables to work out the following, such as the first one, A 3.082 times what 2.09, and B 2.26.52 times what 9.184, C 2.286.3 divided by 17.08, also D 45.80 divided by 6.393. Now the first example we are going to do now is this particular question, 3.802 multiplied by what? 2.09. So this is our number, this is our log. Then what do you write? You write this one, which is 3.802 here. Now look at this. This decimal point in logarithm, this decimal point must be beside the first integer. I mean, it must be before before an integer. And what is an integer? We have both positive and negative integer. This particular query now is an example of a positive integer. So this point is at the normal position. So for it to be here, therefore it's going to be ordinarily 0 points. So after this now, you will now check your log table by checking 38 under 0 difference 2. So checking the log table here now, I have 38 under 0 difference 2. When you check your log table, you're going to check log 38. So log 38 under where? Under 0. That gives me 5798. 5798. Log 38. 5798 under 0. Yes. And the difference of 2. Difference 2, that is 2. So meaning that you are summing 5798 plus 2. And that will actually give you 5800. So you come here to write 5800 because log 38 under 0 gives 5798. So plus 2, that will be 5800. So that is the log of 33.802, which is 38 under 0 difference 2. So you also write this particular number again, which we have here, which is 2.09. You write it here, 2.09. Also look, this decimal point is at the first integer as well. This is going to also be 0 points as well. Then look at log 20 under 9, difference nothing. So log 20, and that log 20 gives us under 9. That gives us 3201. 3201. So I'll write 3201. So log 20 under 9 gives us 3201. Then what do we do next? Because of this sign which is here, this sign is times. So under log, times changes to addition. So I'm going to sum this value together. So if I sum it up, that gives me 0 plus 1, which is also what? 1. 0 plus 0 is 0. 8 plus 2, which is 10. I'll write it 0, then I'll put my 1 here. Then 5 plus 3, 8 plus this 1, that gives me 9. So my decimal point will still be here. Then I have my 0 plus 0, that's 0. So after having this, what do I do next? Then I will need to check my anti-log table. So now checking the anti-log table, you need just to write it here as anti-log. So you can put this arrow if you wish. So anti-log table. On my anti-log table, what am I going to check? Let me check it here. You are going to check the anti-log of this thing here. Now checking here, how do we check the anti-log? You are going to check your anti-log table as 0.90. When you check your four-figure table, you will notice that there is point in front of your values on the four-figure table. So it's going to be 0.90. So when I check here, 0.90 under 0. 0.90 under 0. So checking here, under my anti-log, I have my 0.90 under 0 as 7943. 0.90 under 0 for my antilog. I have my 7493. Difference what? Difference 1. My difference 1 here is 2. So that will be 7493 plus 2. And that is 7943 plus 2. And that is 7945. So I have my 7945 here. Now, where will I put my decimal point? I'll put my decimal point on the number that I have here. My decimal point will be based on the number I have here. Now, this is 0. Remember that I said this is 0 means that decimal point will be on the first integer. So the first integer I have here is 7. So decimal point will be here. So meaning that my final answer will give me 7.945. So that's the final answer to this. So meaning that if you multiply using your calculator by multiplying 3.802 times 2.09, you're going to have 7.945. So this is the first example. Now let's look at another example, which is B, which says that 26.52 multiplied by 9.184. So this example 2, also known as B, this is the number, this is the log. The number is 26.52. How do I check on my 4-figure table? I will check log 26 under 5 difference 2. So checking here now, log 26 under 5. 26 under 5, that gives me 4232. Then the difference of 2 is 3 here. So I have it as 4235. 4235 log 26 under 5 difference 2. That gives me 4235. So what is going to be here is 4235. Now look at the decimal point. What happens to the decimal point? The decimal point is not on the first integer number. Like, it's not on the first number, which is an integer. Mind you, integer begins from 1, 2, 3, 4, 5, 6, 7, and so on. Those are the positive integer. The 0 is not an integer. Why? Minus 1, minus 2, minus 3, minus 4, they are the negative integer. So this decimal point is not on the first integer. So for it to be here, remember your standard form. So if it comes here, which gives you a positive sign, isn't it? A positive sign. If you remember your standard form. So what would I write here? Me carrying this decimal point here once, you make me to have one here. Then I have to put my point here. So that is how it is. Now let's look at the other number, which is 9.184. Now look at this, 9.184. For this decimal point to be in the first positive integer, definitely I'll just write a 0 point here. So writing 0 point here, then I will now look at my 4-figure table by looking at 91 under 8 difference 4. So let me check my 4-figure table here, log under logarithms. Then I will check 91, okay, under 8. 91 under 8 gives me 9628. 9628. 91 under 8. 9628. Difference 4. Difference 4 is 2. So adding it together, that gives me 979630. Difference 4 is 2 here. So if I should add 9628 plus 2, and that gives me 9630. So I will come here and write 9630. So after writing this, what do I do? Look at the sign. It also have a multiplication sign. Multiplication sign will change to addition. So I will sum it up here. Now let me add it up together. So now adding it up together, I have my 5 plus 0, which is what? 5. 3 plus 3, that is what? 6. 2 plus 6 plus 2, that is what? 8. Then I have my 9 plus 4, and that is what? 13. So I will write 3 here, put my decimal point here as well. The 1 will be here. 1 plus 1 plus 0, that is 2. So I have it as 2.3865. Then what do I do? Then I will look for the antilog. So the antilog here is 2435. 2435. Now, where will I put my point? Now, look at this. If my point is here, that means the value here is 0. If my point is here, that means the value here is 1. If my point is here, that means the value here is what? Is 2. So definitely my point is going to be here. Likewise, if the value here is 3, my point is going to be here after this 5. So just that, I will just put a 0 at the back of the point. So my value here is what? Is 2. So I'm going to put my decimal point here. I repeat, if my value here is 0, my decimal point will be here. If my value here is 1, my decimal point will be here. If my value here is 2, my decimal point will be here. So that's how it is. So this is my final answer. Meaning that if you multiply this 26.52 times 9.184 using your calculator, you are going to get this particular answer. Now, looking at this now, this is example 3, which is a C. So we have the number should be 286.3. That means 286.3. So how do we check it on our log table? We are going to check log 28 under 6 difference 3. Log 28 under 6 difference what? Difference 3. So checking my logarithm table here, log 28, that gives me 28 under 6, that is 4564. Difference 3 here is 5, so I have it as 4564 plus 5, and that is 4569. So I have it here should be 4569. Now my decimal point is going to be here. Then what value am I going to write here? Now the value I'm going to write here will come from this. Like I said earlier, your decimal point must be here on the first positive integer. That is first positive integer. So this value here, if I carried it here, that means once. Come here, that means twice. I've carried it twice. So this is going to be 2. This is going to be 2. So I'm going to write it there because I carried this decimal point twice. And remember that I carried it backward. Is it forward? 1, then 2. So 2 is going to be here. Then I'll have it as 2.4569. Also, this other value here we have, which is 17.08. This 17.08, if I want to fix this particular number here first, I can start by saying, carry this decimal point how many times? That's going to be once. So if I carry it 1, that means here is going to be 1 point. 1 point. So my first figure table, I will check 17 under 0 difference 8. So let me check logarithm table 17 under 0. 17 under 0 is 2304. 17 under 0 is 2304. Difference 8. Difference 8 here is 20. So 17 under 0 difference 8. That will be 2304 plus 20. And that gives me 2324. 2324. Then I have it here as 2324. Then what do I do next? Because the question has a division sign. Division sign will change to minus. So I have to subtract. Now let me minus this. Now let's subtract. That will be 9 minus 4. That is going to be 5. Then 6 minus 2. That's going to be 4. 5 minus 3. That's also going to be 2. 4 minus 2, also going to be 2 as well. My decimal point to be here. And then 2 minus 1, and that gives me 1. So I have it as 1.2245. Then what was the next? The antilog. So the antilog is going to be here. You can put arrow here if you wish. Now, what will I check on the antilog table? I'm going to check the 0.22 under 4 difference 5. 0.22 under 4 difference what? Difference 5. So checking here 0.22 under 4. That gives me 1675. 0.22 under 4 is 1675. Difference 5. Difference 5 here is 2. So that will be 1677. So I have it here because 1675 plus 2 will give 1677. So my antilog value here will be 1677. Now, where will the point going to be? That's another thing we have to learn. Now, the point, imagine the number we have here is 1. Like I said earlier, if 0 is here, decimal point will be here on this junction here, at this point here. If 0 is here, decimal point will be here. If 1 is here, decimal point will actually be here. Remember, why? If 2 is here, the decimal point will be here in this place at this junction. If 3 is here, decimal point will be here. You just need to add a 0 at the back here. So final answer is going to be 16.77. So this example 4, known as the letter D, the number is 45.80. So what do we do? If you have to carry the point first, this point needs to be here. So it's going to be, that means we are shifting it once. So it's going to be 1 point, like that. 1 point, because I shifted it once. It has to be on the first integer here, which means the point needs to be on the first integer. I've explained what an integer is for you. We have positive integer and negative integer. This particular one now is a positive integer. Positive integer start from 1, 2, 3, 4, 5, 6, 7, and so on. While negative integer starts from -1, -2, -3, -4, and so on. So if the point is here now, then it's going to be 1 point. Then I'm going to check my 4-figure table, check the logarithm table, check 45 under 8, difference 0. So 45 under 8, difference 0. So 45, that is under 8. 45 under 8, that is 6609, difference 0. So on the logarithm table, there's nothing like difference 0. That means you are going to ignore that away. So that would just be ordinary 45 under 8. So 45 under 8, that is 6609. 6609. So then I will come here and write 6609. Then I'll write the second number, which is 6.393. Now look at this, 6.393. This decimal point here is at the normal position. So it's just going to be 0 points. So it's going to be 0 point. Then I will check 63 under 9, difference 3 on my 4-figure table. So 63 under 9, 63 under 9, that is 8055, difference 3. 8055, difference 3 is 2. So 8055 plus 2, and that is 8057. So 8057. 8057 will be here. 8057. So what do? I will subtract because of the division sign we have from the question. So I will subtract. If I should subtract here, then I have it as 9 minus 7, that gives me 2. So 2 will be here. Then 0 minus 5 actually is impossible, so you have to borrow 1 from here. Here will be what? 5. Then put a 1 here, that gives you 10. 10 minus 5 is what? Is 5. So I have my 5 here. Then 5 that remains here, this 5 here minus what? Minus this 0, and that would automatically gives you what? Gives you 5. Sorry, let me use this blue. So that will give you 5 here as well. Then here is 6. 6 minus 8 is impossible. Definitely you are going to borrow 1 from here. So if I borrow 1 from here, giving it to this place, here becomes 0. Then I have it as 16 minus 8, and that gives me what? That gives me 8. So my 8 will be here. 0 minus 0, that's 0. So I have the answer should be 0.8552. Then what next? Then I'll look for my antilog. So my antilog, you can put arrow if you wish. Now, what will I check on the antilog table? I will check 0.85, difference under 5, difference 2. 0.85 under 5, difference 2. So if I should check 0.85 under 5, difference 2, 0.85 under 5, that is 7169. 7169, difference 2. Difference 2 is 3. So 7161, difference 2 is 3 plus 3, and that gives me 7164. 7164. So I have it there, should be 7164. So 7164. Now where will my decimal points be? From my previous example, because of this value we have here, which is 0, so decimal points will be here. So the final answer is 7.169. Meaning that if you divide 45.80 divided by 6.393, you are going to get 7.164. Now this is another one which we say calculation of power and root using logarithms. Remember, that is our other subtopic, which is what? Power and roots. Now the example we'll be looking at is these examples on the board, saying use tables to calculate the following. A, 5.632 raised to the power of 4, and then B is 7.214 raised to the power of 3, and C 4 root 35, 4 root 35.81, and D 3 root 927.8. Now let's start with what? With A, which says 5.632 raised to the power of 4. Then this is what you're going to write. You're going to write the number here, and the log is going to be here. So now imagine, let's start with this. This decimal point is at the appropriate place. Like I've said earlier, I said if it is here, that means definitely 0 is going to be here. Then you have your point here, because it is beside the first integer. It is beside it. I mean, this decimal point is beside the first integer. Remember, if it is here, that means I must have to shift it to this place, and I'm shifting it once. So me shifting it once, I need to replace here with 1. If it is at this place, at this junction here, that means I have to carry it 2 times. 1, 2 to this place. I'm carrying it twice. 1, 2, 2 have to be here. If it is here, then I have to carry it 3 times. 1, 2, 3, and 3 will be here. But from the question, the decimal point is here, meaning that I'm not shifting it anywhere. It is at the normal position. So I'll just write 0 point. Then I will check my 4-figure table. I will check log. Under the log table, I will check 56 under 3 difference 2. Now let me check under logarithm table. 56 under 3. 56 under 3 is 7505. 7505 difference 2, that is 2. So 7505 plus 2, and that gives me 7507. So I will come here and write 7507. So after writing 7507, which other thing again do you have? I have this power of 4 here. Now whenever you have power, what do? You multiply. You multiply this answer you have here times this 4. So whenever you have raised to power of 2, raised to power of 3, raised to power of 4, like this example B now is a raised to power of 3, meaning that your answer you have here under this log, you multiply it by what? By the power. So for this one now, I'm multiplying this value here by what? By 4. That is the rule in solving logarithm using table. So I'll multiply here by what? By 4. Because of this power here. Now multiply here by 4. Now let's multiply 7 times 4, that is what? 28. So you are going to write your 8 here, you put your 2 here, then 4 times 0, 4 times 0, that's what? Is 0 plus this 2, you have your 2 here, then 4 times 5, that's 20, you're going to write 0, keep your 2 here, and 4 times 7 is 28. 28 plus this 2, that's 30. So you still write your 0, and then you keep your 3 here, then 3 plus 0, that's 3. Sorry, 7 times, let's come again. 7 times 4 is 28. 28 plus this 2, that's 30. You write 0, you keep 3 here. So 4 times 0, that's 0, plus this 3, then you have your 3 here. So now where will you put your decimal points? You put your decimal point by what? By counting the number before the decimal point. Here, this is before. So which are the values like 7, 1, 2, 3, 4. This is 4. 1, 2, 3, 4. Can you see that? So this is 1, 2, 3, 4. You count these numbers here. Then how many is then how many from here to? That will be 1, 2, 3, 4. So your decimal point will be here. You are going to again. You are going to count 1, 2, 3, 4. So once you count, because they are before this decimal point, so they are before the decimal point. So it will now make you to also count from here as well. 1, 2, 3, 4. Then your decimal point will be here. So we now have it like this now. The next thing to do is to now take it to our what? Anti-log. The anti-log. Now, in the anti-log now, you can put the arrow if you can put the arrow if you wish. So what are we going to check on the anti-log table? On the anti-log table now, remember the anti-log has 0.00. Yes, you should hold your 4-figure table whenever you are working with this, and you should have known how to check the four-figure table, like how to look at the four-figure table for this. So looking at the anti-log table has 0.00. So we are going to check under the anti-log table by checking 0.00 under 2 difference 8. 0.00 under 2 difference what? Difference 8. So let's check it together. 0.00 under 2, that is 1005, and difference 8 is 2. So 1005 plus 2, and that gives us 1007. So I will come here and write 1007. Now the next issue is, where will I put my decimal point? Remember, if it is here, that means this value here is 0. If it is here at this place here, that means this value here is 1. If it is here, that means this value here is 2. Then if it is here, that means this value here is what? 3. So therefore my decimal point will be here. So if my decimal point is here, that means I need to extend by writing a 0 here. It does not mean you just have to put it, just put a 0 here. So this is my final answer. Meaning that if you find 5.632 raised to power 4 using your calculator, you should actually get 1007.0. You can find that out using your calculator by pressing 5.632 raised to power 4, and you are going to get 1007.0. Now let's go to the next example. So this is the next example. B says 7.214 raised to power of what? Of 3. So now this decimal point is at the normal place, so I'll have to put the 0 points here. Then what would I check on my four-figure table? I will check 72 under 1 difference 4. So 72 under 1 difference what? Difference of 4. 72 under 1. 72 under 1 is 8579. 8579. Difference what? Difference 4. Difference of 4 is what? Is 2. So I will say 8579 plus 2. 8579 plus 2. And that will actually give me 8581. 8579 plus 2 will give me 8581. So I will come here and write 8581. So after writing 8581, what would I do next? It has the power of what? Of this 3 here. Meaning that we are going to multiply 0.8581 multiply by 3. So let's multiply by 3. So while multiplying, 1 times 3 is what? 3. 8 times 3 is what? 24, because 8 times 1 is 8, 8 times 2 16, 8 times 3 is 24. So I will write my 4 here, then actually put my 2 here. Then 5 times 3 is 15. 15 plus that 2, that is 17. So I will write 7 here and put my 1 here. Then 8 times 3 is also 24 again. I mean this 8 times this 3 is still 24, plus this 1 here, and that gives me 25. So I'll write 5 here, then put my 2 here. So 0 times 3, that is what? 0. Plus these 2 that we have here, that is what? 2. Now, where will I put my decimal point? You will count 1, 2, 3, 4. The number before the decimal point, that is 4. To make it to count this place too, 1, 2, 3, 4. Then you have to put a decimal point here. So if I should multiply 0.8581 by 3, I will get 2.5743. Then what next? My anti-log. So on my anti-log, I can put this arrow here. Then I will check on my anti-log table, I will check 0.5743. 0.57 under 4 difference 3. 0.57 under 4. Under 4 is 3750. Difference what? Difference 3. Difference of 3 still give me 3. So 3750 plus 3, and that gives me 3753. So then I'll come here and say 3753. Now the issue now is, where will I put my decimal point? Remember, if you put decimal point here, that means the value here is 0. Put the decimal point here, that means the value here is 1. Put the decimal point here, that means the value here is what? 2. So my decimal point will be here. So I have my final answer here should be 375.3 as my final answer. So if you find the cube root, if you find the cube of 7.214, I mean, if you find 7.214 raised to the power of 3, you are going to get 375.3. Now let's move to the next example. Now this is example C, which is the number 3. So which says 4 root 35 or 35.81. So this is it. Remember, this decimal point needs to be carried to this first integer, which is the 3. The first integer here is 3. So I need to shift decimal point from here to this place. How many times am I shifting it? Once. So that will be 1 point. Then on my 4-figure table, I will check 35 under 8 difference 1. So 35 under 8. 35 under 8 here is giving me 5539. 5539 difference 1. Difference 1 here still give me 1. So I have it as 5540. So I will come here and write 5540. Now, after writing that, I have 4 roots. Now, the principle of this thing is, the principle of power and roots is that if it is power, you multiply. Like this example A is power, we multiply. Example B is also power. I mean, raised to power, we multiply. But example C and D, which is root, what are we going to do? We are going to divide. So I will divide 1.5540 divided by 4. So let's divide. Divided by what? By 4. So now, how do I divide? Now let's go. Let me write the division sign very well. This is divide. Now how do I divide? If you want, no, when we are multiplying, we're saying 4 times 0, 4 times 4, 4 times 5. But in division, you need to start from this. Start from this place. You start from this place. So by saying 4 in 15, 4 in 15, that is what? 4 in 15 will actually give you, that will be 2. 3. Okay, 3. So 4 in 15 will give you 3. So let me write my 3 here. Then after that, it's going to remain that will be 3. Yeah. So 4 in 35. 4 in 35 will actually give you 4 in 35. That will give you 8. So your 8 here is going to be here, and that will remain 3 as well. So put your 3 here. Now 4 in 34 again actually give you 8 again. So write your 8 here, then you have your 2 here, and finally 4 in 20, that will give you 5. So put your 5 here. So that is the best way to divide without using calculator. So after that, where am I going to put my decimal point? Remember, you count 1, 2, 3, 4. You have 4 here. Then you come here again. You say 1, 2, 3, 4. So you put your decimal point here, 0 points. 0 points. So now I have it as what? As 0.3885. If I should divide 1.5540 divided by 4, then I have it as 0.3885. So the next thing is to look for the antilog. The antilog. You can put your arrow here if you wish. So I will look for the antilog of 0.38 under 8 difference 5. 0.38 under 8. 0.38 under 8 is 2443. Difference 5. Difference 5 here is giving me 3. 0.38 under 3 under 8 difference 5. And that will be 2443 plus 3. And that will be 2446. So I have it as 2446. Now, where will I put my decimal point? Remember, 0 is here. 0 is here. That means it has to be here. So I have it as 2.446. Meaning that if you find 4 root 35.81, you're going to get 2.446. So this is example D. See the same procedure we have been following since. So we have, then this decimal point is not the normal position, so it has to be on this place, on this junction here. So I need to shift it how many times? Let's count. 1, 2. That's twice. Me shifting it twice, now write 2 here. Put my decimal point here. Then after that, I will check my 4-figure table by checking 92 under 7 difference 8. So I will check 92 under 7 difference of what? Difference of 8. 92 under 7 here will give me 92 under 7. That gives me 9671. 9671 difference of 8. 9671 difference 8 here gives me 4. So 9671 plus 4, and that is 9675. So I'll come here and write 9675. So after writing 9675, because of the roots that we have, 3 roots, meaning that we are going to divide it by what? By 3. So I will divide this answer by what? By 3. Now let's divide. Without using calculator, let's divide. 3 in 2, you know it's not possible. You start your division from here. But if you are multiplying, you start from here. So then 3 in 29. So then 3 in 29. 3 in 29 is going to give us what? 9. So I will come here and write my 9. So if I write 9, that's going to remain 2. So the 2 will be here. So 3 in 26, that's going to give me 8. So my 8, I'll write it here. Then what is going to remain? It's going to remain 2. So the 2 will be here. Now 3 in 27. 3 in 27 will give me 9. So I'll write my 9 here. And also, it's going to remain nothing. Then 3 in 5. 3 in 5 will give me 1. So 1 actually remainder 2. So, well, the remainder of 2, you may ignore, you may write it, you may just leave it like that. Because of, if you write remainder 2, it will be like as if, this is a long division, so you'll be having like 2 points, something, something, and so on. So it's actually going to be 9891 remainder 2, or you can ignore the 2. So where are we going to put the decimal point? Decimal point is going to be, let's count it, 1, 2, 3, 4. So if you count 1, 2, 3, 4, where would decimal point is going to be? Count 1, 2, 3, 4. So it's going to be here. So once it is here, it makes it to put a 0 here. So now, meaning that if you divide 2.9675 divided by 3, you are going to get 0.9891. Now let's look for the anti-log. So you can put this arrow if you want. Now, the anti-log 9 is now going to be 0.98 under 9 difference 1. 0.98 under 9 difference 1. So 0.98 under 9. 0.98 under 9. That gives 9750. Difference of 1. Difference of 1 here is 2. That will be 9752. So I will come here and write 9752. So where will I put my decimal point? Remember, the 0 is here. Can you see that? The 0 is here. So my decimal point is actually going to be here. So I have my answer as 9.752. 9.752. Meaning that if I look for 3 roots 927.8, I'm actually going to get, I will definitely get 9.752 as my final answer. So these are more examples for we to practice. More examples for we to practice. This is still mathematics for SS1. You can check new general mathematics for all these examples we are solving here. So now, the example says we should calculate the following. A says the root of 56.3 multiplied by 39.5 also multiplied by 8.64. Now, this is the solution. We have the number and the log. 56.3. What do we do first? This decimal point is not at the appropriate place. Then you need to shift it to this first positive integer. So shifting it once, like if you shift it once, then we have it as what? 1 point. So we shifted it once, then that is what? 1 point. Then after shifting it once, on our logarithm table, we are going to check 56 under 3, difference nothing. So 56 under 3, 56 under 3. 56 under 3 gives us 7505. 7505. So I will come here and write 7505. So After I write 7505, then the next number we have here is what? 39.5. So 39.5, imagine that too. The decimal point is not on the normal place, which is supposed to be. So I will also shift the decimal point once. I should shift it here, then I shifted it once, it's also going to be 1 point. So I have my 1 point here. So having 1 point there, then I will check my four-figure table, then I will check 39 under 5. Four-figure table, 39 under 5. 39 under 5 gives me 5966. 39 under 5 gives 5966. Difference, nothing. So I will come here and write 5966. I'll write 5966. After writing that, then I have another number here which says 8.64. I will come here again and say 8.64. Look at this decimal point for this 8.64 is at the normal position. That is where it should be. So if it is there, meaning that I will just come here and write the 0 point because I am not shifting it to anywhere. It is there like that. So I will check my four-figure table by checking 86 under 4. So 86 under 4 will actually give me 86 under 4 is going to give me 9365. 9365. 86 under 4 is 9365. I will come here and write 9365. Now, what will I do next? The three numbers have times. I mean, times connected the three numbers together, meaning that I am going to sum the three together. Now, let's do the addition together. So let me put my addition sign here. So I will sum up the three together like this. Okay. So summing it up like this, we're actually going to be 5 plus 6 plus 5. I mean, this 5 plus this 6 plus this 5. That gives me 16. I'll write 6 here, then you can put your 1 here. Then 1, the 1 plus 0 plus 6 plus 6. This one you kept plus 0 plus 6 plus 6. So that will give you 13. So you write 3 here, then you keep your 1 here. Then we have it 1 plus 5 plus 9 plus 3. 1 plus 5, that is what? 6. 6 plus 9, that is what? 15. 15 plus 3, that is 18. So you write your 8 here, then you put your 1 here again. Then 1 plus 7, that is 8. 8 plus 5, 8 plus 5, that is 13. 13 plus 9, that is going to be 22. 13 plus 9 is going to be what? 22. So you're actually going to write your 2 here and keep your 2 here. Then 2 plus 1 plus 1 is just 4. For this is addition, then your decimal point will be at the same junction. So we have it as 4.2836 by summing them together. Now, what again are we going to do? You will notice that they all have this square. They have this square root, rather, not square, it is a square root. They all have this square root together. So meaning that if 2, without putting 2 here, putting ordinary square tells us that 2 is here. Putting ordinary square root here tells us that 2 is actually here. So, and remember the example we did under power and root. When we are doing power and root, the examples I gave to you then. So, you notice that we are dividing. Whenever we see root or whenever we see square root or root, what do? We divide. So here now, 2 is here like this, because even if they do not put the 2, if it is cube root, 3 will be here, 4, sometimes 4, 5, and so on. But this particular one, it does not have anything here. But because of this square root, automatically we know that 2 is here. So we are going to divide this 4.2836 divided by 2. So because of this square root we have here for everything, so therefore we are going to divide it by 2. Now let's do our division properly as well. Then 2 in 4, you can see I started my division from this particular place. 2 in 4, that gives us what? 2. So I will write 2 here. Then 2 in 2 in 2, I mean 2 in this 2 that we have here, that is what? 1. So I will come here and write my 1. So 2 in 8, this 8 that we have here, and that is what? 4. So I will come here and write 4. Then we have 2 in 3. Now let's look at this very well. 2 in this 3 is what? 1. remainder 1. So I'll write the 1 here and I'll put my remainder here. So 2 in 16. 2 in this 16 that we have here is 8. So I will come here and write my 8 here. Now, after that, where will I put my points? Don't forget, you still count. 1, 2, 3, 4. That's 4, right? Then let's count 1, 2, 3, 4. So my decimal point will be at this junction. Then after that, what will I do? I will look for my antilog. Now, looking at that antilog now is going to be at this junction. So I can just write my antilog here. You can put this arrow if you wish. So the antilog is going to be 0.14 under 1 difference 8. 0.14 under 1 difference 8. So let's check the antilog table. Let's check 0.14 under 1 difference 8. So 0.14 under 1 difference 8. So that gives me 0.14 under 1 is 1384. 1384 difference 8 is giving me 3 here. So 1384 plus 3, and that gives me 1387. 1387. That's the answer for the antilog. Now the thing is, where will I put my decimal point? Now I'll put my decimal point by considering this value that is here, which is 2. 2 is here, right? So let's look at it. If I should put it here, that means 0 is here. If I should put it here, my decimal point here, that means 1 is here. If I put my decimal point here, definitely that means 2 is here. So I'll put my decimal point here. So the answer I'm having here is now 138.7. 138.7. So that is the answer by finding the square root of 56.3 times 39.5 times 8.64. Now let's go to the next example, B. Now in this example 2, this is the B part, which says that 403.9 all over 779.62, everything in bracket, raised to the power of 3. Now let's start with the solution by saying number and log, whereby we start with the first number, which is 403.9. That decimal point is not on the appropriate place. I mean, it's not on the normal place, so we need to be beside the 4. So by counting it 3 times, which is what? 1, 2. Sorry, 2 times, which is what? 1, 2. So if I should put this decimal point here, 1, 2, that means I'm shifting it twice. So here is going to be 2. Then I'll put my decimal point. I'll put a point there. So after that, I will not look at my first figure table. I will look at 40 under 3 difference 9. So 40 under 3, that will actually give me 6053. 40 under 3 is 6053 difference 9. 6053 difference 9 is 10. Yes, 10. So that will now give me 6063. So I'll come here and write 6063. 6063. So that is it. Then the next number I have here is 79.62. So I will come here and write 79.62. This decimal point, I will need to shift it just once to this place. That will give me 1 point. I'm shifting it once to the first integer number, which is what? 7. So I'm shifting that point away from in front of that 9 to where the 7 is. So I'm carrying it once. For me carrying it once, that means it's going to be 1 point. I will check my fourth figure table by checking 79 under 6 difference 2. So 79 under 6, 79 under 6, that is 9009. Difference 2 is 1. And that will be 9010. 9010. So I'll come here and write 9010. So that will be 9010. So it has a division sign. You can see the division sign here. So for this, then I'm going to what? I'm going to minus. Division, under logarithm, division will replace minus. So I'm going to subtract. So let me subtract these things together. So if I should subtract 3 minus 0, that is what? That is 3. Then 6 minus 1, that is what? 5. 0 minus 0 is 0. 6 minus 9, that's actually impossible. Then I'll borrow 1 from here, making 16, and here will remain 1. 16 minus 9, that is 7. So I'll come here and write my 7. My decimal point will still remain at the same point. 1 minus 1, that is 0. So I have it as 0.7053. Then if you study the question very well, the both numbers are enclosed in a bracket and have a cube. Yes, you can see it here. So in a bracket and it has cube. So like my previous example, I told you that whenever it has cube or square or anything power, we are going to what? We are going to multiply by that value. So we are multiplying this 0.7053 by this particular 3 that is here. So let's multiply times 3 because of this power. We are multiplying because of the power that is there. So I'll multiply 0.7053 multiplied by 3 because of this power that is here. Now let's go by multiplying. Saying 3 times 3 is 9 like this. 3 times 5 is 15. I'll write 5. I'll keep my 1 here. 3 times 0 is 0 plus this one that I keep here, which is what? 1. Then 3 times 7 is 21. I'll write my 1 here and keep my 2 here. So 3 times 0, that's what? 0. Plus these 2 that I have here, that is what? 2. Then where would I put my decimal point? I will count this value here. 3, 1, 2, 3, 4. You make me to put it 1, 2, 3, 4. I'll put my decimal point here. So what would I do next? I will now check the antilog. So the antilog, you can put your arrow here if you wish. So the antilog now is now 0.11 under 5 difference 9. So let me check my antilog table. 0.11 under 5. The 0.11 under 5 is 1303. 1303 difference 9. Difference of 9 here is 3. Then I have it as 1306. 1306. So I will come here and write 1306. Now the next thing is, now where will I put my decimal point? Remember that if I put my decimal point here, that means 0 is this number. If I put my decimal point here, that means this number here is 1. If I put my decimal point here, that means this number here is 2. So my decimal point to be here, and the answer will be 130.6. So that will be my answer. So meaning that if I should divide 403.9, which is this, divided by 79.62, then I cube my answer. I mean, I find the cube of the answer. I should be getting 130.6. So now let's move to the next example. Now let's look at this example C. This example C now, in these more examples that I have here, example C says 17.2, this is it here, 17.2 all square. Now let's work it step by step. So this is the first number we have here, 17.2. This one, we need to be very careful about this particular example. It's kind of complex, so you give it more attention. So 17.2 square. Now let's go with this first. 17.2, this decimal point is not on the normal point, normal position. What do? We shift it once. When it comes here, that means 1 point. Then, because we shifted it once, make me to write 1 here. So now we have it as 17.2. So I will check my 4-figure table by checking 17 under 2. Let me check 17 under 2. Difference nothing. So 17 under 2, I have it as 2355. 2355. 17 under 2 is 2355. So I will come here and write 2355. Then, following this rule of this square, whenever it has power, what do? You multiply. So let's multiply this value by 2. If I should multiply by 2, then this should be 5 times 2, 10 is 0 here, put 1 here. 5 times 2, 10 plus this one, 11. 1 here, keep 1 here. 3 times 2 or 2 times 3, that is 6, plus this one, 7. Then 2 times 2, which is 4. Then 2 times 1, which is what? 2. Then where do I fix my decimal point? By counting 1, 2, 3, 4. Also count here 1, 2, 3, 4. Fix your decimal point here. So I am done with this aspect. Let me start it here. Then we move to the next one, which is 4.93. You can see it from this angle here, 4.93. I will write it under this number, 4.93. Looking here, this decimal point is at the normal position. So meaning that I'm going to write a 0 point at this junction here. So I will now come to my 4-figure table and check 49 under 3 difference nothing. 49 under 3. 49 under 3 is 6928. 6928. I will come here and write 6928. So after writing 6928, you will observe that multiplication times connected this value and this value together. Times connected this value here and this value here together. So, and remember, I told you whenever times connected number things together in log, we use plus. So I will sum up this value together with this value. So let me add them up together. Now adding them together, now I have it as 0 plus 8, that is 8. 1 plus 2, that is 3. 7 plus 9, that is what? 16. So I'll write 6 here, keep my 1 here. 1 plus 4 plus 6. This 1 plus this 4 plus this 6, that gives me 11. I'll write 1 here. My decimal point will be on the same spot, keep my 1 here. So that one I kept plus this 2 plus 0, that gives me 3. Meaning that I am done with the numerator. Numerator, which is 17.2 square times 4.93. Now, let me work on the denominator. So, I can actually just asterisk this place. Let me keep it as well. Now, let me work on the denominator. The denominator now is, look at the value, is 675000. We have 40 there. That is 6750000. So fine. For this now, where will I put my decimal point? Like, what will I do to this? Remember that I said the decimal point needs to be here. Decimal point must be here. So how would I start? Meaning that, remember, if I put my, normally decimal points can be here. When writing numbers, if you remember, if you are listing something, you can actually write, maybe if you are listing, maybe list 3 animals, if you want to write, you write 1, you can write goats, you can write 2, after 2 you can write monkey. If you write 3, you can actually write, let's say rats. Okay, so this decimal point is something like as if you are using it to end a number. So this one too, let's assume decimal point ended this number. So this decimal point must be at this junction. It must be here. So let's see how many times you are going to carry it. That's going to be 1, 2, 3, 4, 5, 6. You are carrying it 6 times. So I will just come here and write 6 points. Let me clean this to avoid confusion. So I will come here and write 6 points. Then what will I check on my 4-figure table? I'm going to check 67 under 5. If there is difference 0, I will check difference 0 and ignore the rest zeros. So 67 under 5 in my logarithm table. 67 under 5, I have it as 67 under 5, that is what? That is 8293. Difference 0, there is nothing like difference 0 here. So I only write my 8293. So I will come here and write 8293. 8293. Now, this 6750000 has cube roots. It has 3 roots, which is also known as cube root. So the cube root it has, what do we do to it? I will divide by 3. Remember the principle? I will divide by what? By 3. I will divide by 3. So if I'm dividing by 3, now let's divide. 3 in 6, that's what? 2. I'm writing 2 here. 3 in 8, that's what? 1. Remainder what? So, sorry. 3 in 8, that is what? 2. I'll write my 2 here. Remainder what? Remainder 2. Let me put my 2 here as well. Then 3 in 22, that is 7. I'll write 7 here. Remainder 1. Let me put the 1 here. 3 in 19, that will actually be what? 6. 6. So 6 is here. Remainder 1. Let me put my 1 here. Then 3 in 13. That is actually what? 4. So let me write my 4 here. Remainder 1. So just ignore that one that remained. So where will I put my decimal point? My decimal point will be, count this number, 1, 2, 3, 4. Then I will count here as 1, 2, 3, 4. My decimal point will be here. So I have it as 2.2764. 2.2764. So having it like that, what would I do next? I already have my 2.2764. When I divide 6.8293 divided by 3, I have it as 2.2764. Let me also asterisk this. Now, if you should observe that looking at the division connected this value here and this value here was linked together by this division sign. Look at it here, by this division sign. So what will I do? Now, everything on this numerator ended where? Here at this junction. Take note. And also, everything at this denominator ended where? At this junction. Can you see that very well? So what am I going to do now? So I will just have to what? Have to subtract the both, because division connected them together. So which will make me to subtract the both. So now look at this. I said this value and this value. This is the end of the numerator value, as you can see it here. And this is the end of the denominator value, as you can see it here. So now let me, division connected them together, which is this division. So I will now subtract the answer we got from this numerator, which is this value, subtracted from this answer we got from this denominator, which is this value. So let me write it here because of space. Then I have it as 3.1638 divided by what? 2.2764. So I will subtract because it has division sign. Now let's subtract. 8 minus 4, that is what? 4. 3 minus 6 is impossible. I'll borrow 1 from here, put it here. Here remains 5. Then 13 minus 6, that is what? 7. Then here remains 5 as well. Let me borrow 1 from here. If I borrow 1 from here remains 0, and I have here as 15. I have here as 15. 15 minus 7, 15 minus 7, that is 8. So here is 0. If I borrow 1 from here, put it here, makes 1 to be 10, and here remains 2. 10 minus 2, that is what? 8. My decimal point still remain on the same junction. 2 minus 2, that's 0. So I have my subtraction of 3.1638 minus 2.2764 as 0.8874. Then what is the next? It remains the antilog. So let me find the antilog here, antilog. So you can actually put your arrow if you wish. So the I'm going to check is 0.88 under 7. 0.88 under 7 is 7709. 0.88 under 7, that is what? 7709. Difference 4. So difference 4. Difference of 4 here give me 7. So meaning that I am adding 7709 plus 7. And that should going to give me 7716. That will give me 7716 because 0.88 under 7 is 7709. Difference what? Difference of 4. Which difference of 4 here gives me 7, and that's going to be 7716. So I will come here and write 7716. Now the next thing is that where will I put my decimal point? Remember, if decimal point is here, meaning that this value here is 0, decimal point is here, this value here is 1, decimal point is here, this value here is 2. So this value here is 0, then my decimal point is going to be here. So that's the final answer. Final answer now end up with 7.716. So if you do this, if you use a calculator to operate this, you are going to get 7.716.